Sunday, there will be a test, okay, which will be based on the same chapter, that is real numbers, okay. So whatever we have discussed so far, you will be able to answer all the questions. Please do practice beforehand carefully all the question from your book, all the, if you are getting any extra question, previous year question, do it carefully. There will be a test on coming Sunday, okay. Is it okay? Okay, so we were talking about few important results. Let's take it again over here. Okay, that previous, in our previous class we have just taken it. We have just taken the topic. We have just touched this concept, and we said that we'll be discussing it in this class. So few important result was there. That is, if we'll be having rational number, and if we will add it with any irrational number, the result will be irrational number. Now, when I am saying rational number, that means, again, I would repeat, it can be whole number, it can be natural number, it can be integers. Okay. So rational number means whole number, integers, natural number. We are talking about all the numbers. So any number added with irrational number is irrational number. For example, you can take, let's say we are taking 2. Rational number, it's a rational number, okay. 2 can be represented in the form of p by q, where q is not 0. The numerator and denominator has to be integer, so it is fulfilling all the criteria of rational number. That's why 2 is also a rational number. We already know that. Plus irrational number, if we'll be taking any irrational number, let's say root 2 or maybe root 3, we will be taking this result 2 plus root 3, it is irrational number, okay. Simply you can understand that if you will be having any non-terminating decimal number, if you will be having any non-terminating, non-repeating decimal number, let's say 3.679312581346, like this, which is just keep on going and keep on going without repeating any pattern. And if you will add any number with that number, if you will add 2, 3, 4, 5, or maybe any decimal number, or let's say I'm going to add 2 over here. Can you see? Can you see when we are adding the decimal number, we know that we have to keep decimal below decimal. Okay, we have to maintain this decimal below decimal while doing the subtraction, while doing the addition. So if we'll be writing this number, the top one like that, and below it I'm writing 2. Decimal below decimal means 2 means 2.0000. 2 means 2.00. That's why I have written 2 just below 3. And decimal below decimal we have maintained. Now we'll be adding it. So rest of the number will be like that only. 67931258136 dot dot dot. After decimal, all the number will be just like that. Okay. Before decimal, 3 plus 2 will become just 5. So can you see the result is irrational only? Can you see that? Can you see? Let me know. Are you getting it?
Yes, ma'am.
Yes, ma'am.
Okay. Similarly, if we'll be having This was about addition. Okay, rational plus irrational is irrational. Similarly, we'll be having the subtraction, that is rational minus irrational. If we'll be having the subtraction like this, that is rational number minus irrational number. Just a second. If we'll be having rational number minus irrational number, the result will be again irrational only. So instead of doing the addition, even if we will do the subtraction, just like the previous example which we have done on the right hand side, this one. Okay, can you see it? When we will be doing the subtraction, we will end up getting non-terminating, non-repeating decimal number. Okay, and hence the result will be irrational only. So rational plus irrational, irrational. Rational minus irrational, irrational. If we will be doing the multiplication, even if we will be doing the multiplication, that is rational number times multiplied with any irrational number. Let's say we are having a rational number, let's say 1.5 we are having a decimal number, okay? And if we will be doing the multiplication of 1.5 with any irrational number, root 2, root 3, which in actual is non-terminating, non-repeating, okay? If we'll be multiplying this 1.5 with 2.97341582667, which just keep on going and keep on going and keep on going. When you will do the multiplication, here we don't have to maintain decimal below decimal. We will be multiplying the number and then we will count the number of digits from the last. We will be counting the number of digits, just like if we are doing the multiplication of 2.3 with this 5.6, we just do the multiplication of these two numbers. Okay, 2-digit multiplication, we do it, and then at last whatever we are getting, we just count the digit. Here we are having 1 digit, here we are having 1 more digit. That means from the last two digit we have to leave, and then we will be putting the decimal. This is the rule for doing the multiplication of a decimal number, which you have already seen, which you have already done. When you learn the chapter decimals, there you have done the operations on decimal, addition, subtraction, multiplication, division. So here also, when we will be doing the multiplication of rational number into irrational number, our result again will become irrational. Okay, and if we will be doing the division, then also our result will become irrational only. Okay, if we will do the division between rational number and irrational number, the result will be irrational only. So you can see irrational has dominated in all the cases. Okay, if we are having one of the number as irrational while doing addition, while doing subtraction, while doing multiplication, while doing division, every time we are just getting irrational only. Okay, so that is about when we are applying the operation of irrational number with any other number, that means with rational number. But what about when we'll be having two irrational only? Okay, let's see that. When we will be having, case one is when we will be having irrational plus irrational, irrational plus irrational, then what are we going to get? If we'll be having irrational minus irrational, then what are we going to get? The previous case was about all the other numbers. Okay, real number, we are having real number. In real number, irrational number is there and rational number is there. Everything comes inside real number. Okay, in the previous scenario, we have seen that if we are adding irrational number with any other number, okay, be it a natural number, whole number, we are calling, in general, we are calling it rational. Okay, if we will be doing the same if we will be applying the same operation when in between two irrationals only, then what will happen? Is it again irrational? Let's see that. Okay, if we'll be having irrational minus irrational, if we will be having irrational times irrational, and if we will be having irrational divided by irrational, so when we are having irrational plus irrational, see, it can be, the result can be rational number also. The result can be rational number also, or it can be irrational number also. Why it can be rational also? See, suppose we are having one of the example. Let's say we are having 5 minus root 3, and here we are having plus 2 plus root 3. Okay, you can see we have taken two irrational number. 5 minus root 3, we know that it's an irrational, because in the previous scenario we have discussed that rational minus irrational, rational plus irrational, rational into irrational, rational divided by irrational, all are just irrational. Okay, so this one is irrational. Here we are having rational minus irrational. The result already we have seen. Rational minus irrational. When we will be having 5 minus root 3, it is just irrational. Okay, we have also seen the example that when we will be doing the addition, subtraction, this is how we'll be getting the pattern. And here we can see it clearly. Even after adding the number, we are getting non-terminating, non-repeating decimal number. Okay, that's why it's irrational. So when we will be adding this two, can you tell me what are we going to get? Anyone? 5 minus root 3 plus 2 plus root 3 is what? Am I audible? Aisha, Galvin, Ziana, Harshit.
7.
Exactly. It is 7. It will be just 7. Because when we will open the bracket, when we will add them, root 3 will cancel out each other, and we will just end up having 7, which is rational. So every time, is it going to be rational? No. Every time it will not be rational. It depends upon the number given. Here root 3 is getting cancelled out, but every time it will not get cancelled. Okay. For the other example, if we'll be having, let's say, the same 5 minus root 3 here we are having, but the other number is, let's say, 2 plus root 5. Here we can see when we will add both of them, it is root 3, root 5 is not cancelling out each other, and it will be there. It will be there as it is. And hence the result will be irrational. Got it? Is it clear to everyone?
Yes, ma'am.
Similarly, irrational minus irrational, the result can be rational, and it can also be irrational. Okay, it depends upon the given numbers. Irrational into irrational, again, the result can be rational, it can be irrational. Why? Because the example can be like this. The example can be the first irrational number, 2 root 3. 2 root 3 is irrational number. We already discussed that when we will be multiplying any number, that means any rational number with irrational, the result is irrational. So this 2 root 3 is irrational. Okay, if we will be multiplying it with 5 root 3, which is another irrational, what will be the result? Please let me know. Please do it.
About 30.
Exactly. We will be having 30. How? Because 5 into 2 is just 10. And root 3 into root 3, both the root 3 just collaborated together. They will come and sit inside one square root sign. and hence we will be getting a pair. For a pair we can take a number. That's why we say that root 3 into root 3 is just 3, root 5 into root 5 is just 5, root 7 into root 7 is just 7. Okay, so here 30 we are getting, which is a rational number. That's why here for the multiplication, when we are having irrational into irrational, the result will be, it can be rational. It can be irrational. Similarly, for the division also, it can be rational. Either numerator, denominator will get cancelled out. It will become just a rational number, or it will be irrational. So let's summarize everything, whatever we discussed so far. When we were having rational number plus irrational number, the result is irrational. When we were having rational minus irrational, the result is irrational. When we were having the multiplication of rational and irrational, the result is irrational. When we were having the division between rational and irrational, the result is irrational. Similarly, what about when we were having both as a irrational, the result, it depends upon the given number. The result can be anything, any real number. It can be rational, it can be irrational. Similarly, for the subtraction also, for the multiplication also, and for the division also. Okay, now in our previous class we were talking about proof that root 5 is root 5 is irrational, proof that root 3 is irrational, proof that root 2 is irrational, which we have already done the discussion. Okay, now what if the question is proof that, 2 minus root 3 is irrational? We know that it is irrational, right? Now only we have done the discussion that rational number minus irrational number. Just a second. Yeah. So now only we have done the discussion that rational number minus irrational number is, the result will be irrational. We know that. Here what we have to do, we have to prove it. So if we will be just giving the statement, if we will just give the statement that yes, we know that rational minus irrational is irrational, that will be incorrect. Okay, that will not be correct. So here we have to prove it, that the result will be irrational. How we are going to prove? The way we used to prove for any irrational number like root 2, root 3, root 5. Similarly, here also we will be proving that, but this one is simple than that one. Okay, that one was not that simple. We need to follow certain steps where like the number is dividing the numerator, hence it is also dividing the denominator, which we have taken as a coprime. So we were taking that scenario. Here this will be quite similar to that, but easier than that. Okay, let's see how can we do that. So first, what we were doing previously, if we needed to prove that root 3 is irrational, we were taking the contradictory, we were applying the contradictory method, we were using the contradiction. That let's assume that root 3 is rational number. Now, let me tell you one more thing, that when we are going to prove that 2 minus root 3 is irrational, here in the question, this sentence given that root 3 is irrational, this blue sentence, either it will be given or even it is not given, we will assume that it is given. Okay, given that root 3 is irrational, that means we will assume that we already know that root 3 is irrational. Okay, now again we will not starting the proof of root 3 is irrational. Okay, so we will totally focus on proving this completely as irrational, where it is already known that root 3 is irrational. Okay, so this blue sentence, either it will be given in the question, or even if it is not given in the question, we will assume it that it is already known to us that root 3 is irrational. Okay, now let's start proving it. So contradiction we will be taking over here. We needed to prove it irrational. Okay, in the proof we will start with taking it as a rational number. So we will say that, let's say 2 minus root 3 is rational number. Now, since it is rational number, can we write it in the form of a by b, p by q, where numerator and denominator both are integer and denominator is not 0? Yes, we can write it that way. Let's write it. So 2 minus root 3, we can write it as a p by q, where p and q are integer and q not equals to 0. That is the definition of rational number. Okay, that's why we are writing it like this. Okay, now here what we can do, let's write it, where p and q are integers and q not equals to 0. Okay, now what we can do here, we can change the sign. So this p by q, which is nothing but just a fractional term, we can keep it on one side. Okay, we can just shift it, we can transpose it to this side, beside 2. Okay, and root 3 we will be taking towards the other side. So this negative root 3 on the other side, will it become positive root 3? Yes or no? Yes or no? Aisha, Galvin, who is there? Sumaya, Maha, Harshit,
Yes,
Zian.
ma'am.
Yes or no? Root 3 we will shift to other side and it will become positive root 3, right? Are you getting it?
Yes, ma'am.
Everyone, are you getting it?
Yes, ma'am.
Yes, ma'am.
Okay, so we will be shifting it to other side, and this p by q is nothing but just a fraction. It's just a fraction, like 2 by 5, like 1 by 3. Okay, like 3 by 7. It's just a fraction. So we will be taking it to this side. That side it is positive p by q. This side it will be negative p by q. Is it clear so far? Please let me know one by one, everyone. Then only we'll be moving ahead.
Yes, ma'am, it's clear.
Yes, ma'am, it's clear.
Aisha, Ziana, Harshit,
Yeah, ma'am.
clear. Maha, Sumaya already responded. It's clear to all of you what exactly we are doing. So far, whatever we have done, we have assumed it as rational number. We can write it as a form of p by q. We have just changed the sign. Okay. Now, if we will be taking the LCM on the left hand side, can you tell me, or we can also write it root 3 is equals to 2 minus p by q. See, we are not changing anything. We have just changed the side. The right hand side one, everything we have taken from the right hand side and we have kept it on the left hand side. And everything from the left hand side, we are taking it and we are keeping it on right hand side. We are not changing the equation. Just sides we have changed. Okay. Now, can you tell me on the right hand side, if we will try taking the LCM, what will be the LCM of the denominator?
Ma'am, it will be PQ minus QQ upon Q.
Can you repeat?
It will be QP minus QQ upon Q.
2p minus 2q upon q.
Ma'am, I'm saying it QP minus Q upon Q.
Have I written it correctly the way you are saying?
Yes, ma'am.
Harshit, you said no?
Yes, ma'am.
Okay. Rest of the student, please tell me what is your response. I'm writing it over here. Aisha? Aisha? Galvin?
Ma'am.
Yeah, Aisha. What you are thinking, please let me know. Galvin? See, whatever you are feeling like, you have to tell me. I'm going to write each and everyone's response over here. Ziana is there. Ziana
Ma'am.
is there. Harshit already responded. Who else is there?
Ma'am.
Maha is there.
Ma'am, is it 2Q minus PQ by Q?
2Q minus PQ
Minus
by Q.
PQ. Yes,
Have
ma'am.
I written it correctly, Maha?
Yes, ma'am.
Okay. Yes. Sumaya. What will be there?
Teacher, 2Q minus PQ by Q.
2Q minus PQ by Q. Ziana. Galvin, yeah. Galvin,
Ma'am, I'm getting 2Q minus PQ by Q, ma'am.
you are getting the same 2Q minus PQ by Q. Right,
Yeah,
Galvin?
yeah, that's what I'm getting.
Ma'am, I'm getting 2Q
Okay.
minus.
Aisha, you were saying that you are also getting the same, right?
No, ma'am. I'm getting 2Q minus P by Q.
Okay, Aisha, you said that you are getting 2Q minus P by Q. Right?
Yes, ma'am.
And Galvin, you are getting the same, whatever Maha and Sumaya said.
Yes, ma'am, I'm getting the same, ma'am.
Same like the first one, Aisha one, or Maha
Ma'am,
2Q
like
minus
Maha's,
PQ
like
by Q, and Sumaya also said 2Q minus
yeah,
PQ
ma'am, I'm
by
getting like
Q.
that only, ma'am.
It is 2Q minus PQ by Q, right, Galvin?
Yes, ma'am, I'm getting it like that.
I don't know why your voice is not that clear to me. Have I written it correctly? That you got 2Q
Yes,
minus PQ by Q.
by
Is it
Q.
okay?
Yeah. Yes, ma'am.
It's okay. Perfect. Ziana.
Yes, ma'am. I also got 2Q minus PQ by Q.
Okay, this is what you also got. Okay, let's see what are we going to get. Let me check everyone responded or not. Aisha, Galvin, Ziana, Harshit, Maha, Sumaya. Yeah, everybody responded. Okay, let's check what are we going to get. Okay, what are we going to get? Here, I can see everyone just identify that the denominator will be just Q. LCM will be Q. That is perfect. Yeah. LCM will be Q. Why LCM will be Q? Because the first one's denominator is nothing but just one. LCM of 1 and Q. Whenever there is no common factor, we have to take everything in the LCM. That's what we have learned it. So if we'll be taking everything in the LCM and we will be doing the multiplication, it will be just Q. Perfect. Now this denominator 1, the first denominator 1 became Q. This denominator became Q. So 1 multiplied with Q became Q. Similarly, the same Q we have to multiply in the numerator also. This is how we think. This is how we think that this 1 definitely got multiplied with Q, and then only we are saying the common denominator, that means denominator of both the terms is Q now. So this 1 got multiplied with Q. So since we are having a fraction, we are bound to multiply the same term in the numerator also. Okay, so we are bound to multiply this Q in the numerator also, and it became Q, 2Q. Perfect. Okay, minus sign is there. We will copy paste over here. Perfect. Okay, now the next denominator is Q and the common denominator is Q. So what change is there in this denominator? Nothing. No changes there. Okay, no changes there. Or if you will think that, you can also take it in this way, that there is a multiplication of just 1 over here. So that 1 we will be multiplying in the numerator also. Q is the denominator of the second term, and Q is our common denominator of both the terms. So Q is Q. What change is there? Whatever change is there, whatever extra got multiplied in the denominator, that only we have to multiply in the numerator also. So here Q is just became Q, this Q became Q only in the common denominator part also. That's why we are going to say there is no change in the denominator. Numerator will be as it is. Or we can also say that 1 got multiplied with this denominator. So the same 1 we need to multiply in the numerator also. So P into 1 is just P. So it is 2Q minus P by Q. Yes, Aisha, you are correct. Are you getting it?
Yes, ma'am.
Is it clear to everyone? Always do the comparison like that. The first denominator, what change is there in the first denominator? If you want to check it with the fraction, the number, check it. If we are having 1 by 2 plus 3 by, let me take a proper number, plus 7 by 6 plus just 2. Okay, if we are having these fractions, and if we have to do the addition, what we will do? We will be finding the LCM of the denominators. So 2 is there, 6 is there, 1 is there. LCM of 2, 6, 1. What will be the LCM of 2, 6, 1? Please find it.
Teacher 6.
It is okay, it is 6. Okay, and this 6 we will be writing it over here. This, if you are drawing a bigger line, and if you are writing 6 over there, that means now all the fractions, whatever is there in the numerator, each and every fractions denominator is 6 now. That's why we are drawing a bigger line and we are writing 6. That is, now it is the common denominator. Common denominator. Now our common denominator is 6, which is for the first fraction also, for the second fraction also, for the third fraction also. And how we check? Let's see how exactly we check. We check that 2 became 6. How? Definitely there is a multiplication of 3 over here. So the same 3 we multiply in the numerator also, and we say that numerator is 3. Yes or no? Or quickly you do like that. 2, 3 times 6. So 3, we have to do the multiplication in the numerator. Yes or no? Now the next term, 6, 1 times 6. So 1 we have to multiply in the numerator. Right? This is how you do the calculation quickly. Yes or no?
Yes, ma'am.
Now
Yes,
the second term, this 6 is just 6 only. So is there any change? No change. So numerator also will not change. Or you can also take it in this way, that 6 into 1 is 6. So 1 we have to multiply in the numerator also. So the next term is just 7. The numerator is not getting changed when the denominator is exactly same as the common denominator. Now the next one, 2 by 1. Can you tell me what will be there in the, what shall I write over here? The last term. Please tell me.
12.
Yes, 12. Okay. The denominator was 1. The denominator was 1. The denominator was 1. It changed to 6. What multiplied over here? 6. There is a multiplication of 6 over. Okay. Hence, we need to multiply the same number in the numerator also, and it became 12. This is the concept, and Whatever you do, you have to do it in that manner also only. Okay, you don't have to follow these steps. I'm just trying to clear it so that you can apply the same logic while dealing with the variables, because I have seen students are comfortable with this calculation. They know that 2 became 6, 2 3 times 6, then we have to multiply 3 in the numerator, 6 1 times 6, then we have to just keep the numerator as it is, and then the last term 1 6 times 6, then 6 we have to multiply in the numerator. They do it quickly, but when we will be getting the variables like this p, q and all, they just get confused. So just be clear that what exactly we are doing. Okay, let me know whether it is clear or not to everyone. Galvin, Maha, Sumaya,
Clear, ma'am.
Yes, ma'am.
Harshit. Clear? So we are getting 2q minus p. We are getting 2q minus p by q. Root 3 is equals to 2q minus p by q. This is what we are getting. What is 2q? Q is integer. Initially we have written p and q are integer. So 2 into any integer is just integer. Okay. Now 2q is integer. Integer minus p is also integer. Okay. 2q is integer and p is also integer. So integer minus integer will be just integer. Check it. Integer minus integer. Integer, you can take a positive integer also. Integer minus integer. Okay. Any two integer you take. Any two integer. Integer minus integer. The result will be just integer. So here we can say 2q minus p means what? Integer. The result will be just any integer by q. Q is what? Integer. So integer by integer means what? Rational number. Yes or no? Integer by integer means what? Rational number. But root 3 is irrational. We know that. We know that root 3 is irrational. Even maybe in the question, the statement will be given like that. Given that root 3 is irrational, or even if it is not given, even if this bracket part, even if it is not given in the question, we must know, okay, that root 3 is irrational. We have to take like that in this question. Okay, we are not going to prove that root 3 is irrational. It is already known to us that root 3 is irrational. Instead of root 3, if any other number is there, we must take it that we already know that that number is irrational. Okay. So we know that root 3 is irrational. It can't be equal to integer by integer. It can't be equals to integer by integer. It is not a rational number. This is totally incorrect. We landed at totally incorrect conclusion. This is not correct. Hence, our assumption which we have taken is completely baseless. Our assumption is incorrect. What was our assumption? Let me write it over here. Don't worry, we will be summarizing this concept. If you are getting confused that how we will proceed over here. Here we will write, hence our assumption is incorrect. And 2 minus root 3 is irrational. Let me show you. This was the question. Prove that 2 minus root 3 is irrational given that root 3 is irrational. Given that root 3 is irrational, it can be given. Even if it is not given, we have to take it like this only. Now, how we will start the proof? We will start with the assumption, the contradiction we will be taking as an assumption. Let's assume that 2 minus root 3 is rational number. Let's assume that. Okay. Since it is a rational number, we can write it in the form of p by q, where p and q are integers and the denominator q should not be 0. Okay, that is the definition of the rational number and we are writing it over there. Now we are just changing the side. This p by q we are shifting to other side, and root 3 we are just, what we want to do, we want to just keep root 3 on one side. Okay, we want to isolate root 3. Isolate root 3 means we want to keep it on one side without any other number. So we have kept root 3 on one side and rest of the term on the other side. Okay, after that we have done the simplification and we ended up getting 2q minus p. We are saying that 2q minus p is integer and by q is integer. So integer by integer is just integer. That means integer by integer, it is rational number. Okay, integer by integer is rational number. That's what the definition of rational number says. That if any number can be written in the form p by q, where p is integer and q is integer. So p and like numerator is integer, denominator is integer, it's a rational number, which is not true. We know that root 3 is not rational number. Okay, so our assumption which we have taken initially is completely incorrect. Got it? Only 2-3 steps we have to show and we are done with the proof. Okay, any confusion over here? Any confusion?
No, ma'am.
Rest of the students, let me know. Galvin, Harshit, Sumaya, Maha, let me know.
No.
Aisha,
Yes, ma'am.
is there any confusion over here?
No,
No,
ma'am.
ma'am.
Okay. So instead of this type, this 2 and root 3, any other number can be there, like 5 plus root 3, like 5 minus root 3. Instead of root 3, it can be root 7, it can be root 5. Okay, any irrational number, we will be able to prove it in the same manner. Okay, now even if we are having this type of question, let me take that. Even if we are having the proof which is like this, show that 3 root 2 is irrational. Okay, show that 3 root 2 is irrational here also. Even if it is not given beside the question, that given that root 2 is irrational, we know that. We know that root 2 is irrational. What we have to prove here? We have to prove that the multiplication between a rational and irrational number is irrational. That's what we have to prove here. Where we know that root 2 is irrational. So we will be using the same method. Okay, just like the previous one, we will be starting just by taking the contradiction that let's say it is rational. Okay, let's assume that, let's say 3 root 2 is rational. And since it is rational, we can write it 3 root 2 in the form of p by q. Here, the definition of rational numbers is where p and q are integers and q not equals to 0. Okay. We can write what we have done in the previous question. We have kept root 3 on one side. We have isolated root 3. Here also we will try isolating this irrational number. Isolate means what? Just it must be separately, it must be just single number on one side. Okay, root 2. This 3 we are going to shift to other side. That's how we can isolate this root 2. Okay, so isolating root 2 on one side, p by this 3 we are just transposing to other side. So it will go here, it is in multiplication. On the other side, it will be in division. So it will become 3q, right? Now again, we can see root 2 is equals to p. Integer by integer. Can you see it? Can you see it? Root 2 is equals to integer by integer.
Yes, ma'am.
And hence rational number, which is not true. Okay. Root 2 is equals to P is integer. We already know that. Q is also integer. We already know that. And 3 multiplied with any integer is just integer. So this root 2 became integer by integer. That means rational number, which is not true. Okay, which is not true. We know that root 2 is irrational. Hence, our assumption is incorrect. Hence, our assumption is incorrect. And hence, 3 root 2 is irrational. Is it clear to all of you? But just 2-3 steps. This much only we have to do. Clear? Is it clear? Now prove that 3 plus 2 root 5 is irrational. Please do it in your copy and send me the snap of that. Here also we will be starting with the contradiction method. Here also we will be using the same process. Here also we will try keeping this root 5 on one side separately. Okay? Do it and send me the snap of that. No? Aisha, Galvin, Ziana, Harshit, Maha, Sumaya, do it in your copy and please send me the snap. Okay? Are you doing it?
Yes, ma'am.
Let me know. Are you doing it? Galvin, are you doing?
Yes, ma'am, I'm doing, ma'am.
Aisha?
Yes,
Ziana?
ma'am.
Harshit?
Yes, ma'am.
Maha? Sumaya?
Yes, ma'am.
Don't have the phone with me. No